Hello viewers, welcome once again to Rising Sun Online Math class. If your first time to watch my video, kindly hit on the red button so that you will see a notification whenever a new video is uploaded. So we are still in differentiation, the techniques of differentiation. And in these techniques of differentiation, we have solved the derivative of algebraic function. We have also solved the derivative of a constant. And today we want to solve or look into the derivative of sum and the difference. So, and this derivative of sum and difference you have seen on the board here, we can solve it separately without affecting the signs. What I mean by you can solve this separately without affecting the sign, because it involves plus and minus. Because when you talk about sum in mathematics, talk about addition. When we talk about difference in mathematics, we talk about minus. So here, since it has to do with addition and subtraction, so this differentiation or derivative of sum and difference is done by not affecting their signs. So what I'm trying to say is this: from example, if you're asked to differentiate y as equals to x raised to the power of n plus or minus x raised to the power of z. So how can you differentiate this? So from here now, you can agree with me that this y, we are differentiating y with respect to x. So for the dy, the x of this is equals to, now take the power of x, which is n. Here now, the power of x here now is n. Take this n now, multiply by the x, you have it xn. N multiplied by x, you have it as nn. This n, which is the power of x, reduce it by 1, which is n minus 1. Plus or minus. The same thing here, you have here now, multiply z by x, you have it as zx raised to the power of z minus 1. So the dy dx of x raised to the power of n plus or minus x raised to the power of z is equals to nx raised to the power of n minus 1 plus or minus zx raised to the power of z minus what? 1. So you can see that this did not affect the what? The signs. So solving this does not affect the what? Signs. Now let's take another example of this sum and difference. So you may be asked to find maybe y as equals to 3x squared plus 2x minus 5. You are asked to differentiate this. So since you are differentiating y with respect to x, so how are you going to do this? You say dy over the x of this now is taking the power of x, which is 2, multiply it by 3, which is 2 times 3x. Now the power of x, reduce it by 1, which is x raised to the power of 2 minus 1, plus here we have, here now is power of 1, but you cannot write 2x raised to the power of what? 1. So here now is 1. Take this 1 now, multiply by 2x, which is 1 times 2x. The same one here, reduce it by 1, which is 1 minus 1. So here now is minus 5. And when you differentiate a constant, you get what? 0. So if you don't know how I get 0, you can go back to my videos, my previous videos, how I solve the derivative of a constant. So when you differentiate a constant, you get what? 0. So here, 2 times 3 will give us, this implies 2 times 3 will give us 6x. And the 2 minus 1 will give us 1. So there is no way you can write 2x raised to the power of 1. So here now is 6x. Plus, here now is 1 times 2 will give us 2. And here now will be 2x. 1 minus 1 is 0. And any number raised to the power of 0 is 1. That will say that this one implies that 6x plus, let me separate this. Here the same thing as 2 times x raised to the power of 0. And the 2 and x raised to the power of 0 is equals to 1. So this 2 now multiplied by 1 is 2. That will say that here now becomes 6x plus 2. So the divide x of 3x squared plus 2x minus 5 is equals to 6x plus 2. Because when you differentiate this, you have a constant 2. When you differentiate 2x, what you're going to get is a constant 2. So this is how we get it. So this x raised to the power of 0 is equals to 1. So when you multiply 6x by 2, when you multiply 2 by 1, you have what? 2. Thank you for watching, and may God bless you.